This is section 2.2, video 2. So now we're going to be looking at if we have an exponent on the outside of brackets that have more than one term. So if there's one term in a bracket, let's say 2x squared y to the 3, what you learned in chapter 1 is that you take your exponent and you multiply it to each of the bases. So this one would become 2 to the 3, x to the 3 times 2, so 6, y to the 3. But you cannot do that if you have more than one term in your bracket. Okay, it doesn't work that way. Instead, what happens is you take the entire bracket and you write as many copies of that bracket multiplying each other as their exponents. So here, it would be written like this. If this was a 3, we'd write a third bracket. And then you multiply them accordingly. So here, 2x times 2x gives us 4x squared. Then we do this one, 2x times 1 plus 2x. Then 1 times 2x plus 2x, 1 times 1 plus 1. We're going to combine like terms. So we get 4x squared plus 4x plus 1. So that's the final answer. If you had just taken your 2 and put the 2 on everything in the bracket, you would have gotten 2 to the 2, x to the 2, plus 1 to the 2. Okay, if you had used this method over here, and that would have given you 4x squared plus 1. Notice how this is very different from this. Okay, it's not the same answer. So you can't just put the 2 on everything. It doesn't work if you have more than one term. So you have to multiply the whole bracket out. Okay, that's a very common mistake that people make. So don't fall into that trap. Okay, so the next thing we're going to look at is, what if we don't have just two binomials? What if we have larger polynomials? So here we have a binomial multiplying a trinomial, 1, 2, 3 terms. Here we have two trinomials together, 1, 3, 1, 2, 3. Okay, that's why I didn't really ever like the word FOIL, because you can't use that anymore. But you can still do the first times the first times the second, the first times the third. You can do that, okay? Which is, I just find easier than the term FOIL. So here we have x times x, so we get x squared. Then we have x times y, and then we have x times minus 3. Now we're going to do the second times the first. So you can write this as yx, or you can write this as xy. I'm going to write this as xy, y times y squared, and y times minus 3. Oops. Minus 3y. Okay. Now I'm going to look to see if I have any like terms. Those two are like terms, they're the only ones. So now I have x squared plus 2xy plus y squared minus 3x minus 3y. So remember, I'm writing terms with the highest power in the front. So this is as a power of 2. This is 1 and 1. So this is a power of 2. This is a power of 2. So these three are at the front. It doesn't really matter how I organize them. And then this just has a power of 1, and this has a power of 1. So those are further to the back. So that's my final answer for this one. Okay. Here I'm going to do the same thing. Start off the first one times the first one. So here I have 2r to the 4 first one times the second one, I have negative r to the 3. First one times the third one, I have 2r squared. Now I have the second one times the first one, plus 6r to the 3, the second one times the second one, minus 3r squared, second one times the third one, plus 6r. I'm going to use a different color. Now I have the third one times the first one. So, oh, I'm running out of space. Hold on, let me move this over a little. No, it's not going to work. There we go. So I have the, oops, go away, minus 2r squared. I have the first one times the middle one, so that's plus r, and I have the first one times the last one, that's going to be minus 2. All right, now I need to look for similar terms. So r to the 4. Do I have any other r to the 4s? No. R to the 3s. I do have r to the 3s. R to the 2s. I have one here, one here, one here. I don't know, orange. Let's see. R's and R's. And then whole numbers, just the 2. So now I'm going to rewrite that. 2r to the 4 plus 5r to the 3, and then I had plus 2 minus 3 minus 2, so minus 3r squared, and 6r and r plus 7r minus 2. And in terms of our powers, we have 4, 3, 2, 1, nothing. So this is our final answer. Okay. And then last one, you have this special case. It's called a product sum difference. So a product sum difference is when you have two brackets that are almost identical. The only difference is that one of them you have a plus and the other one you have a negative. So if you look at the brackets here, 3x, 2y are exactly the same, 3x, 2y. One you have a plus in between, one you have a negative in between. So when I multiply this out, the middle is going to disappear, just like it did in this, over here in this example. So let's do that together. So 3x times 3x, so we get 9x squared. 3x times negative 2y minus 6xy. 2y and 3x, positive 6xy. You can write it as yx, doesn't matter. Notice this is the step that makes them disappear, because we have a negative 6xy, we have a positive 6xy. So those are going to end up canceling each other out. And then 2y and minus 2y, so we get negative 4y squared. All right, so now we're going to combine our like terms, this one and this one. And we have 9x squared minus 6xy plus 6xy. When you add them together, that becomes 0. So we don't need to have it anymore. 4y squared. We're left with just this. Okay. If we looked at our very original one, 3x, if we had squared that, 3 squared is 9, x squared is, well, x squared. And then subtract, just like subtract. And then we had 2y, so 2 squared is 4, and then y squared. Okay? But it only works if one's a plus and one's a minus. It doesn't work if they're both pluses or they're both minuses. So my recommendation would be to multiply it out every time, and you just notice that these cancel. Some people like to skip directly from this step to this step, but you're more likely to make mistakes that way. Okay. So now you can do page 77, number 2, A, B, and C, and number 3, A, C, and E, just those letters. And then number 75, or page 75, number 6, just A and C. And then that's it for the work for this week. And we'll continue next week with factoring.